All right, welcome back. We're going to look at some scatter plots in this video. And the idea being is that we want to be able to represent data in a lot of different ways. And that means that we have something called bivariable data. Now, when we talk about central tendencies, we talk about mean, median. Those were single variable data. Meaning that we had just the one piece we're looking at analyzing just that one part. But now what we're looking at as well is what happens when we're comparing the change in two different pieces of data. So what I have here is some data I've actually created. Just recently watched a home improvement show on a network that's devoted to doing those types of shows. And one of the at the very end of the video, this was a home that was being renovated in California, Northern California, and a member of the household had expressed how they wanted a redwood tree in their yard. And being the studious renovator that this individual was, they went ahead and put a redwood tree in the person's front yard. And this struck me as being massively a horrible idea. Redwoods are wonderful trees. They're massive and they're beautiful, and they are very much needed in Northern California. It's one of the few places they will actually grow. But the climate's just perfect for them in that little spot. But one of the problems with growing a redwood tree in that area is because of how big they get. I don't know how much you know about redwood trees, but they will grow to be 400 feet tall and 40 feet at the base, and they can grow as much as 2 to 3 feet a year in ideal conditions. So I just thought, well, that'd be an interesting little math problem for us to look at real quick to see what happens when we do some things. So I just created a bunch of years here, and based on the growth factor, I just created some data. I went looking for some data, and I couldn't really find what I was wanting to use to kind of reverse engineer what I wanted to do with this activity. So based upon what I was seeing, I just kind of created some numbers here. And the idea being is that the tree, under ideal conditions, meaning it's getting lots of water and sun, it will grow as much as 3 feet per year. So it was planted in the front yard. It was 5 feet tall, and then the following year, they watered it really good that first year, so it grew 3 feet that year, and then it continues to grow at normal rate based upon weather conditions. Now, what's really interesting about the redwood tree is it only grows about 6 to 12 feet into the ground for its root system, but the root system can grow out laterally 100 feet in all directions. And in a forest, these redwood trees' root systems will intertwine with each other and actually wrap around each other, and the trees will become physically linked underground and will actually support each other, both from a nutrient perspective and from a structural perspective. So the root system isn't terribly deep for a 300, 400 foot tree, but it's very wide, and that's where its stability comes from. So I just kind of created this data. Now, what I did here, and this is kind of giving you some little tricks and tools to use as we go through the course, because you are going to need to use Excel or Google Sheets. I'll use Excel mostly because it's my favorite platform to work on in spreadsheets. But I also wanted to give you, you can use Google Sheets if you don't have Excel, and if you need some examples on how to work through that, I can do that. And if you are a Mac user and you use numbers, we can work with that as well. I can put some videos out there, just ask me, and I can see about putting those out there and doing some of these examples in those scenarios as well. So what I did is I actually just typed in the first number here at the top of 1997 for no particular reason other than just seemed like a good year to start. I can change. What I did was I actually went through here and I made every other cell in that column based upon the cell before it. So if I change the first cell to being now 2023, when that tree was planted at the height of 5 feet, you can see that all the other numbers cascade and change into the next number, which is good. Now, my next column is the actual growth. So maybe we need to go here and label these things. So I'm going to right click on this right here. If I'm a Mac user, you're going to hit Control click on there, and I'm going to insert a row above that, and this is going to be the year, and then I'm going to arrow over, and this is going to be the height, which I'll just use it as an H there. You can spell out the entire word if you want. Now, next thing is when we graph this in something called a scatter plot is what we're going to do first, is these are really big numbers to deal with. So why don't we do this? I'm going to again control click here or right click, depending on what your use is, and I'm just going to enter in a blank column right there. And I'm going to say, instead of year, I'm going to say years of growth. Oops, there we go. All right, and I'm going to just kind of go over here and wrap that text so I can see the whole thing at one time. And then I'm going to make this column, I'm going to set equals, I'm going to make it that column right there minus 2023, right? Which makes it year 0. Okay, you could also do 1. So if you want to do that in a different way, you want to make this year 1, we just do minus 22 there. That's just going to make the numbers a lot smaller for us. Now what I can do is copy that, highlight all the cells I want to copy it to, and then paste those in. Now I'm looking at 20 years worth of growth, and my numbers are 1 through 20. I can hit escape and it'll clear out that little dotted line around that box there. Now these two columns are a lot easier to deal with and work with. Now I can come over here somewhere. I'm just going to click my cursor right over there to the side, and I'm going to go to insert, and then I have a bunch of options to choose from. So here I have all these different types of columns in there, and over here I have these others like that. I have these things, and if you just kind of hover on one, it'll actually tell you what you're looking at and what you're using there. So if you ever forget, like, I don't know where to find this piece, you can just kind of click and hover and let it sit there for a second, and it will tell you exactly what you're looking at. So here are the histograms and boxing whiskers plots and all that stuff, and then here it actually says scatter. So there's the actual scatter plot right there, and that's the one I'm wanting to use. So I'm just going to click on that, and I can move this anywhere I want. Now, if you notice, it's just blank. There's nothing in there. All right. Okay, so I'm just going to undo that. Apparently I did something wrong, right? Well, what I did wrong was I didn't pick my columns. I'm going to pick this column, and then I'm going to pick this column. And you can do Shift or Control or Command, whatever your computer system is set up to do that with. And I'm going to pick those two columns to be the ones I want to look at. Then I can go back to Insert, and I can go back to my scatter plot, and this time it's going to create the scatter plot for me. Now I'm going to make this a little bit bigger so I can see it a little bit easier. Now you can look at this and see that, yeah, it's kind of wavy, as you would expect an actual growth to occur. You'd have, and if I just kind of click to the side there, you notice that it gets rid of those highlightings I had there. And if you look at the data itself, there's sometimes, like there's a dry year, it doesn't grow very much, and the wet year it grows a lot. One year I had it actually showing that it grew only half an inch, or half a foot rather, and that's what we're kind of seeing here reflected here. Now, one of the things we want to look at is what's the overall growth rate for the tree over this long-term period. So what I can do is I can actually click back on that, notice it highlights everything for me, and for me it actually pops up add chart enhancement, quick, all this other stuff. So if I click a chart enhancement, what's that? Well, one of the things I can do is pick a trend line, and then I can pick a linear trend line right here, and there it is. There's my linear trend line. If I click on that line, I double click on it, it'll actually pop over here to the side some stuff that I can see. And one of the things I can make it do or ask it to do for me is, yes, I want it to be a linear. I can display the equation and display the r-squared value, and we'll talk more in detail about both of these things. And it may not be super easy to see either of these, but what these mean is it says y is equal to 1.4ish, x plus 4.17, and then r squared is equal to 0.99. Now I'll go ahead and tell you, the closer to 1 that r squared value is, the better the fit the equation we created is to the actual data. I engineered this data, so you'd expect it to be really close. So anytime you see a really, really close value to 1, it means one of two things. The data has been engineered like I did here, or it's a really good fit. And we'll talk about how to tell the difference between those in the coming days in different videos. But right here we're saying that the overall growth rate for this thing over the course of 20 years is roughly 1.4. And to put that in context with our problem, it's 1.4 feet per year is the growth rate of this. So after 20 years of that tree being in the ground in front of that front house, the height of the tree is 34 feet, theoretically. from now. So in the year 2042, that tree would be 34 feet tall in a yard that was massively small, terribly small yard, in a house on the land which was only roughly 15, 20 feet tall. So you're talking 20 years from now, that tree being twice the height of that house, and it's just going to keep on growing, which is one of the reasons why it kind of popped out as me being like, that doesn't seem like a great idea to do that. But we can look at this and we can see long-term effects on this. So when we start expanding this idea out and looking at other ways that we can use scatter plots and create these regression lines, which is one of the things we're wanting to do with this, the reason we're interested in that is because then what can we say if we were looking at the growth rate over the last 20 years? Because this would be going forward in 20 years. If we go back to my original idea here, if we had observed another tree, and we went back to this being 1997 up to a few years ago, and of course that changes all those values. See, it changes in real time, so I want to make this 1996 there. Okay, and then I'm going to have to copy and paste that to all those values there like that. Now it changes it in real time. Notice the values are all the same as they were before. I've just readjusted that. Okay, so the original year here doesn't really have as big as an effect because we've reset this to years of growth here. It has the exact same trend line for us, which is useful. So now based upon this would be historical data, and then we can make a prediction of what it would be like in the coming years. How big is this tree going to be in the coming years? So if we'd reset this so the tree was planted, and so that 2023 is right now at this last data point, we can make a prediction of what's going to happen in 2024 all the way up to 2040 and beyond. And the further out we get from that, the worse our prediction is going to be. But that's why we're doing this. So we create this scatter plot, and this is a really easy way to reset your data so the numbers are easier to work with. They're just smaller to work with here. And then we just plot that, and we treat these as ordered pairs, because if you look at these values right here is the point. I can get it to pop up there. There we go. There are those individual values right there are the actual points that we have here, 1, 5. So you go over 1, up 5. There's that first point. You go over 2, up 8. There's that next point of 2, 8. And then you can even hover on those values, and they'll tell you, if I can get a little bit, there we go. There's 3, 9. There's the next point. There's the next. It's kind of hard sometimes to get on those values, but you should be able to kind of hover around those values and see the points we're dealing with. There we go. 11, 19. All those points are from the data plot, and we just graph those over and up. The easiest way to do this is on paper and pencil is to use graph paper to do this. So that way you have nice, accurate, clean grid that you create. And if you're doing this electronically, having Excel or Google Sheets or numbers do this process for you comes out with a nice, clean graph. Please pay attention to the directions as you go through this. If all is being asked for you is a scatter plot, then that's all you need to post. If what you're being asked to find the trend line or the regression line is what we're going to be really finding there, then you're going to want to start with the scatter plot and then go from there. And we're always going to want to start with the scatter plot and see what the basic trend is here. And it looks like the basic trend is a linear equation going up. So it'd be an increasing trend line. All right, thank you, enjoy, and please let me know if there's other videos or other information that you need, and I'll try to post it as we go. Have a good day. Take care.